Ethical hacking carries immense financial stakes. Recently, ethical hacker Gerhard Wagner discovered a double-spend vulnerability on the Polygon network. By reporting it, he earned a $2 million bug bounty and prevented what could have been an $850 million theft. To practice these skills safely, you need to build a penetration testing lab. The host machine running this simulation requires a baseline of at least 8 gigabytes of memory. This memory supports 3 distinct virtual machines running simultaneously inside Oracle VirtualBox. You will configure the Oxygen mail server, deploy the Kali Linux 2021 OVA, and build the Metasploitable 2 target. This image displays the network settings for the Oxygen virtual machine. Notice the selection in the Attach To drop-down menu, Host-Only Adapter. You must select this option for every virtual machine. This ensures your testing environment communicates internally, completely isolated from your real-world local network. A misconfigured lab exposes your actual network to the very vulnerabilities you are trying to test. Strict network isolation is the required first step before any offensive tools are deployed. During deployment, your virtual machines may crash immediately upon startup. This silent failure state usually happens when Microsoft Hyper-V is running concurrently with VirtualBox on your host machine. To bypass this hypervisor collision, open PowerShell as an administrator. Type bcdedit/set hypervisor launch type off, hit enter, and restart your computer. This command disables the conflicting Hyper-V service. This menu shows the VirtualBox setup process. The Kali Linux OVA imports seamlessly as a pre-packaged appliance. Metasploitable 2, however, requires manual provisioning. Looking at the hard disk selection window, you have to manually select the radio button to use an existing virtual hard disk file. This panel confirms the final configuration state for the intentionally flawed Metasploitable instance. You can verify the memory size is set to 512 megabytes, and the specific metasploitable.vmdk file is successfully attached as the virtual hard disk. Knowing how to handle the structural differences between prepackaged OVAs and raw VMDK files is a necessary skill before you can launch a single exploit. With the lab running, the enumeration phase begins. By executing an Nmap discovery scan across your target infrastructure, you can locate open ports. Finding ports 80 and 443 open verifies that active web servers are running on the target. You have confirmed the web server is active. Before launching heavier, noisier scans, what lightweight command line tool should you use right now to extract the server's exact software banner? The correct tool is Netcat, executed with the NC command. Netcat establishes raw HTTP connections to port 80, executing a banner grab to reveal the exact version of the web server software. Expand your command line portfolio further. Use wget to securely download target files from the server for offline inspection. At extreme speed, deploy enum for Linux against Unix targets to map out their directory structures, Active Directory, and Samba frameworks. These command line tools gather specific, raw evidence. You are extracting the exact software versions and directory maps required to build your final executive report. Next, escalate to heavy vulnerability scanning using Nessus Essentials on the host-only network. This report lists flaws discovered during deep web application test scans. Notice the severity breakdown displaying critical issues. Handing a client massive, unorganized severity scores provides noise, not a remediation plan. To make this data actionable, you must map the identified Nessus flaws directly to standard global databases. You match the scanner output to the MITRE CVE list and the NIST National Vulnerability Database to find standardized vendor fixes. Identifying a vulnerability proves you can operate a scanner. Mapping that flaw to recognized NIST and CVE frameworks demonstrates that you can translate technical findings into the standardized language used by security professionals worldwide. All of your gathered data must now be synthesized into a professional penetration testing report. This is a standard technical report format. Looking at the table of contents, the document architecture begins with an executive summary and an introduction to outline the goals and high-level findings. Next comes the scope and the detail sections. This is where your raw, Nmap, and Netcat findings live. Notice the rigid numbering convention, 4.1, 4.2.1. You must format your technical discoveries systematically so the reader can navigate the data. The details section contains raw technical facts. The subsequent summary and recommendation sections serve a different purpose. Here, you translate those technical facts into business risk, outlining specific mitigation steps sourced directly from NIST databases. At the end of the document are the annexes. Annex C is critical. This is where you place the raw, unedited outputs from your command line tools so the client can independently verify your evidence. The complete Capstone workflow follows a strict pipeline. First, isolate the lab with a host-only adapter. Second, enumerate targets using Nmap and Netcat. Third, scan and map vulnerabilities to NIST. Finally, report the findings from Executive Summary to Annex C. Finding a vulnerability in a target environment is a technical achievement. But that achievement holds zero value for the client unless it is translated into a clear, professional report that tangibly protects their infrastructure.